Hey, what's up? This is Randy. Today we're going to learn all about what happens when we shift a graph horizontally and or vertically. Here we go. So we're going to start today by looking at the formula that we use for shifting functions horizontally and vertically. And then we'll talk about what part of the formula tells us about the horizontal shift. And then we'll talk about what part of that formula tells us about the vertical shift. And then some examples. Please, for your own good, remember to pause before I do each example so that you can try it yourself. So the formula that we use for shifting functions is actually this second one right here. But this first one is what we're going to call the core function. And this core function, f of x equals x to the power of a, is going to function basically as our starting point. Now, g of x equals x minus h all to the power of a plus k is what we're going to use to interpret the shifts of our graph. So one way to think about this is that f of x shifts and becomes the graph g of x. Now, this exponent a could be any variety of numbers. It could even be a fraction, but in our case, for this lesson, we're going to have positive integers for a. So 1, 2, 3, 4, 5, so on and so forth. So before we get into some example problems, let's talk about what part of this formula right here tells us about the horizontal movement and what part of the formula tells us about the vertical movement. So this part of the formula plus k determines the vertical movement of the graph. If we have plus some number, that means that the graph will be shifted up. And if we have minus some number, that means the graph will be shifted down. So as a couple of quick examples, if we had plus 3 in place of plus k, that would mean that our graph is shifted 3 units up. Similarly, if we had minus 3 in place of plus k, that means that the graph would be shifted 3 units down. And if we have no k, that means that our graph does not shift up or down. So far, this is hopefully pretty intuitive because many of you would probably think of plus as up and minus as down. But now let's look at what happens with this part of the formula, minus h. This will be less intuitive. Okay, so minus h tells us about the horizontal movement. But if we have minus something, that will indicate a movement not to the left. Minus will indicate movement to the right. And if we have plus something in place of minus h, that will indicate movement to the left. See how it's like counterintuitive? So for example, instead of minus h, if we had minus 3, that would tell us to move 3 units to the right. And in the same way, instead of minus h, if we had plus something like plus 3, this would tell us to move 3 units to the left. So something that helps me remember these movements is that plus k is intuitive. Just think plus k intuitive. But minus h is the opposite of intuitive, right? Minus you'd think would be left, but it's right. And plus you'd think would be right, but it's left. All right, there it is. So the plus k is intuitive and the minus h is not intuitive. Now let's do some actual examples. All right, so just to help us through these questions, I decided to put our core function and our formula for shifting functions on the screen here. All right, they say the graph of f of x is shown in green in the image provided. Okay, so f of x is x squared. The equation for the green parabola. And they say, what could be the equation of the blue parabola in the image? And we're just going to call it g of x. So g of x is this blue parabola. But what is the full equation for the blue parabola? Now, just so that we're all clear, I chose to use f of x here and g of x here because those are pretty common conventions. But you really could see something like a of x or something like k of x. We're just using f of x and g of x this time. All right, so we need to somehow figure out the rest of this equation right here. In order to do that, we just need to figure out what was the horizontal and vertical movement when we went from this green parabola to this blue parabola. Let's figure out what that shift was. So let's just choose one point on each graph, and then we'll figure out where that point shifted. So we're going to just use the vertex here. So the vertex on the green parabola is 0, 0, and the vertex on the blue parabola looks like it's at 1, 2. Okay, so how do we shift? We went 1 unit to the right and 2 units up. So we know that this +1, the horizontal movement, corresponds to the -h part of the formula, and this +2 corresponds to the +k part of the formula, because the +2 is the vertical movement. All right, so now we just need to fill in this part of the equation and this part with -h and +k respectively, but instead of h and k, we need to use the right numbers. So as we talked about on the last slide, if we have a movement to the right, that will correspond to a minus of that number. So it's going to be -1 for -h. Right, remember, counterintuitive, minus feels like it would be left, but in this case, because we already have a minus in the formula, -1 is to the right 1. And we know that the vertical movement is intuitive, so a +2 will give us a +2 for +k. So our final equation for g of x is g of x is equal to x minus 1 all squared plus 2. So there it is. That is our equation for the blue parabola. Now let's try another example. So they say describe the horizontal and vertical shifts that take place when we shift f of x to the position of g of x. So this is actually quite a bit faster. We just need to know, what does -4 tell us about the horizontal movement, and what does +5 tell us about the vertical movement. So as we've discussed, this -4 counterintuitively indicates that the graph will move 4 units to the right, and the +k part, the +5, just as we would intuitively expect, tells us to move 5 units up. All right, let's do a real quick hypothetical. What happens if we have x plus 4 instead of x minus 4? That would tell us that we're moving 4 units to the left as opposed to the right. But this problem was -4, so it's 4 units to the right. All right, let's look at one more example here. Given the following function f of x, this time f of x is x to the power of 4, write an equation for g of x such that g of x is a transformation of f of x. 5 units to the left, okay, this will be the -h part, and 7 units down. That's the vertical part, which would be the +k part. So our a is obviously the same, it is still 4, but the question is, what do we put in for -h and what do we put in for +k? So let's start with the +k part. We know that that part is the intuitive one. So 7 units down will tell us that the +k is going to be a minus, right? Down sounds like minus, and it's 7 units. Okay, now what about the -h part? All right, this is counterintuitive. So if the shift is to the left, you intuitively would think that that would be minus, which tells you that it should be plus, because we already have a minus in that formula. So the -h part will be +5. So there's our equation. G of x is f of x shifted 5 units to the left and 7 units down. All right, now that we have seen the formula for shifting functions, we have discussed both horizontal and vertical shifts and have discussed 3 example questions, we are finished. See you next time. Hey.